Mr. Zhu. So today we are talking about the calculus problem, right? The position, velocity, and acceleration. And the most importantly, we need to know the relationship with these three. Okay, just I will draw a graph and randomly a constant line, and this is position line. Then I will write the velocity. This is the velocity. This is the position velocity. And now, do you know what's the acceleration? Yeah, it's here. Acceleration is 0. Yeah, do you know why? Today I will tell you. Velocity is the relationship with the velocity and the position is the derivative of the position is the velocity. So it's like if this function is st, so this is the vt, this is at. So st equals s. This is the derivative of the position. So s derivative t is equal to velocity t. So the velocity is the derivative of the position. Otherwise, well, the velocity also has the sign, which is negative, positive or negative. Do you know what? Just like to go left, turning left is the negative, and going right is the positive, and moving away is the positive, and maybe it's the back towards is the negative, right? So the velocity also has the speed. This will I will show you in the later graph. Okay, let's talk about the acceleration, right? Acceleration is the derivative of the velocity. Yeah, so it's the second derivative of the position. So it's second derivative. So it's the second derivative t s is equal to acceleration t. Okay, this is the problem, right? Okay, we generally about the to kind of know the relationship with these three. So next we will have to do some work. Okay, here's the example. We know this is the position function, so we need to know, the question is we need to know after 2 minutes what's the velocity, and after 2 seconds what's the acceleration. So we need to find the derivative of the function. So 2 negative down here is 6t, 2 minus 1 is 1, and plus t. Yeah, oh, plus 5, sorry. So this is the equal to. So this is velocity function. Then we plug. So we know after 2 minutes we should to plug t equal to 2. So we plug into the function. So it's like it's equal to 6 times 2 plus 5 is equal to 617. So now we need to know the acceleration about the after 2 seconds. So what's next? So we need to do the second derivative of the position. So we know the first, so then we do the second. So it's t 6. Oh, yeah, this is constant, right? So there's no So this is about 6, so it's constant, there's no acceleration. Okay, this is kind of easy problems, and we need to know next. We need to the one question I want series of talking about is what's the derivative, right? What's the derivative? Can you tell me? Or I will tell you. It's the quantifies an instantaneous rate of change. So what I will show you in the next 6 graphs to show the relationship with the position, velocity, and the acceleration. Okay. Okay, this is 6 graph is different. It's constant, this is constant line. Okay, this is all like the position graph. Okay, so we look at this graph. The position increased, right? Increased. So the next is so because the position increased, so the velocity is positive. So velocity is positive, and because the velocity is this is why it's constant, right? So the velocity is constant. So the acceleration is equals 0. It's acceleration. This three is all about the increase positive. So this three is kind of positive, decreasing, or decreasing positive position. So the velocity is all positive. So if the positive is decreasing, so the velocity is all negative. So what's the relationship with the velocity and acceleration? So x is, because this velocity is increasing, so the acceleration should be positive. Okay, then the velocity is kind of like to slow down. This is speed up, and this one slow down. So the velocity is decreasing. So the acceleration is negative. Right? Do you know the positive one? So next we discuss the negative one. So yeah, the same thing. The velocity is constant. So the acceleration, because the velocity is negative, so acceleration. Oh, this one is also sorry. This one acceleration also equals 0. There's no relation. And then this one is kind of like increasing, right? This one different. This is increasing. This is they are all negative, but this one velocity is increasing. Increasing, same thing. Velocity is positive. Decreasing, same thing. Decreasing. Well, acceleration is negative. Okay. Yeah. So about this information, then finally we will get finally I will do some examples for you. Okay, this is velocity. Oh, this is position, sorry. Okay, so this is, so the position, this is increasing, so the position halfway, and this is increasing, so the acceleration is increased, so, and this one is decreasing, but still it's increased. The position, I'm sorry, it's about position. This one is all, they are all, this is decreasing, so the velocity should be negative, and this is point. And so this is a constant line, so we know that the acceleration is equals to. Oh, wait a minute. Okay, today we have the position and velocity and acceleration. I think you understand.